create a system which can clean river water. Many rivers of India is basically in a very bad state because of two things. One is industrial effluent which is coming in, and second, domestic sewage which are coming in. In Odisha, there is a river Mahanadi, and they did experiment on Mahanadi. Around Mahanadi, there are many industries, not industry like big industry. Rather, you can like a small scale industry, house industries. People they have it. They are engaged in dyeing, dye business, and dyeing is not like big industry. You will find every city has a particular area in which some people will engage into the dyeing business, and it is kind of non-point source of pollution. Pollution source can be of two ways. Point source are those which are big industries. We know that this is industry, yahan se pollution aa sakta hai, and government send the people over there, officials over there, and they check the entire thing. They compel the industry to put all the safety equipments to trap the pollutant, and it doesn't allow pollutant to go into the environment. So that is point source. Big factories or industrial areas, we have their names and address and what they are doing. And managing this point source is easy. But the people who are doing dye in household only, that is non-point source. It is more dangerous because obviously we don't have any track of it. अब कोई घर में कोई dye कर रहा है, you never know. And the person is doing dye business because traditionally that is the work that this person or family used to do. And you know that dye chemicals are very dangerous. They are poison. They are so great poison, potent poison, that you don't even put your hand into it. They either wear gloves or they use some stick or something like that to dye it. But once the dyeing is done, cloth has been dyed. So leftover dye, they simply throw in the drainage. And through the drainage, it will come to what? River. So river is getting heavy chemical pollution, dangerous one, poisonous, which can kill the kill the aquatic life. At the same area, the same household will also be producing lots of domestic sewage that will also come. So now this part of Mahanadi was receiving a lot of chemical pollutant and a lot of biological pollutant. Chemical pollutant from dye and biological pollutant from sewage. That created a lot of issue. So this nanoflex is one such thing. If we sprinkle on the water of Mahanadi, so this nanoflex will break dye. It breaks dye. When the dye is chemically broken, then obviously its impact will go down. Chemically degraded. If you degrade, it's all fine. And after degradation of this dye, H2O2 will be a byproduct, hydrogen peroxide. And this will kill what? Bacteria. You get my point? So breaking dye is what? Solution of chemical pollution. Or let's say not solution, you can write. Rather you can say like it brings down chemical pollution down. So here what happened? That chemical pollution came down, and this is what? Biological pollution. That also came down. And this is what? It's a byproduct. So these nanoflakes are a kind of catalyst which will work upon dye first. Now this dye will broken down. One of the byproduct of the dye will be hydrogen peroxide. This hydrogen peroxide amount will increase, and hydrogen peroxide is kind of medicine only. In hospital also we use it to kill the bacteria and pathogens. So that is how they have done it. So they have developed, they have experimented, they got a very good result, but still we are not using it, right? Many of the nanotechnology, we are not using it, in spite of the fact they offer very good solution, because we know very less about them yet. We need to be very aware that we do not do mistake that we have done in past. 1930s around, plastic polymer make the way into the human civilization. And we were overwhelmed by the benefits of plastic polymer. Fiber आया, artificial fiber. How big it was? Because for fiber, you were dependent upon cotton, silk, jute, linen. It's all natural one. Natural fiber is a long, tedious process. You have to plant cotton, you have to harvest it, you have to convert it into thread, then you have to put it onto the machine. It's a very difficult process as compared to plastic polymer. In a plastic polymer, chemically you are making it. So we adopted plastic in such a way that now in our bloodstream, plastics are there. Because we never thought the side effect of it. Similar kind of thing we are not going to do with the nanotech. We know that there is a lot of possibility, but what we are exactly doing right now, हमने एक बार महानदी पे sprinkle किया, conducted an experiment, and then we got the result. और महानदी में भी नहीं किया, we got the water of Mahanadi in a tank like a structure in the same area. We put it over there. We analyzed the water quality, it improved. But we are not using in Mahanadi because obviously we don't know that if this nanoflakes is being eaten by fish, then what kind of impact it will bring in? What if these nanoflakes are being absorbed by the plants, aquatic plants, then what kind of impact it will bring in? What if this water is being used for irrigation in the cropland, then what kind of impact it will bring in on the soil fertility and the crop production? What if this this water is being consumed by the animals and humans, then which kind of impact it will bring in? So there is something called safety assessment that need to be done. It's a new technology. We know not many thing about it. लेकिन potential तो है ही. And potential can be used in a maximum way only when you are aware of its side effect. So you can write, develop nanoflakes which can minimize chemical contamination, and biological contamination in water bodies. Biological contamination in water bodies. It has been successfully demonstrated. In Mahanadi. Successfully demonstrated in Mahanadi. Right? So we got two important aspects. So in environment part, if they ask, go with it. First is how to minimize greenhouse gas, and second, how to minimize the pollution, right?